All right, 9.4, 9.5, 9.6. Here we go. So we're starting with nutrients for plants. We're talking about fertilizers here. So we got inorganic versus organic fertilizers. So compost is a really good example of organic fertilizer. And as you can see down there on the bottom, there it is. It's got worms, worms and bugs and dirt and soil and paper and recycling things and so on, so on, so on. So compost, like we saw in the video, can be basically kind of a mixture of basically anything that's basically plant based. Like personally at home, like our eggshells and our, the stems of the banana peels and the green parts of strawberries, basically all those kind of things. Basically, just put in a big pile. Eventually, just kind of creates new dirt, new compost, and that's great to use for fertilizer. Now, there's also inorganic fertilizer. And inorganic fertilizer is basically like the stuff you can buy at Home Depot or a potting place, something like that. Okay. What this is, basically the problem is that the more that we use of that inorganic fertilizer, the less recycling there is. And the recycling I'm talking about is that the nitrogen and phosphorus isn't as recycled. Because basically it's not like as usable. It can be used, but it's not as good as the organic stuff. And nitrogen and phosphorus are typically the limiting factors for plants. And that's why fertilizer is used, to give them that nitrogen, to give them that fertilizer. Next page, page 219, talks about over-fertilization leads to eutrophication and dead zones. And we've talked about that a little bit with the Gulf of Mexico dead zone. So this picture sums it up really well here. So basically, if you got a whole bunch of fertilizer happening, it eventually runs off into the water, causes eutrophication. So like the green and red algae blooms, it basically use up all the oxygen when it decomposes, so nothing can live there. So that's what happens when there's over fertilization. Now, sustainable farmers, what they do, they focus on precision agriculture. So they basically, like we've talked about, is that drip irrigation system, and they also monitor their soil very, very, very routinely to check the chemical makeup of it, to kind of see if they need fertilizer and where they need the fertilization to happen. All right, so page 220. Now we're going to be talking about pollination. So more than 100 crops and a third of the U.S. diet relies on bees. Those guys are the pollinators. And as we talked about the other day, the bee population is going down and down and down. And that's because pesticide use as well as habitat loss are causing them to decline. And that's a really bad thing, because if we can't have bees pollinating for us, then it starts becoming a man-made thing where basically humans have to go out and pollinate it, which is much less efficient and much more costly. So the price of food will really start to skyrocket. All right, page 221. Now we're getting into conserving agricultural resources. And this one's a little bit of a longer section. So we're talking here about the land and soil degradation. So the soil degrades faster in drier areas, which makes global warming a threat to more areas. And we talked about that today, actually. We're talking about California droughts. And one of the reasons they're happening more often is because of global warming. Like the conditions for rain are getting smaller and smaller and smaller. Okay? Erosion is also a big problem. You can see basically just it's eroding the farmland right there. It's basically removing that really good soil from the top land, or from the top soil, the top horizon, removing that away, which is really bad, obviously. Okay? Erosion going to deposition. Okay? That process creates new soil, but it happens very, very, very slowly. So like I was just talking about, erosion removes the topsoil, which is the most vulnerable part of the soil. And then deposition, it basically gets deposited elsewhere, and it creates soil, but real slow. Last thing I wrote there is know the ways in which humans have made erosion happen faster. And those are those 3 bullet points right there. So we got over cultivating fields through poor planning or excessive tilling, basically plowing. So basically you're just trying to just get more and more and more and more and more food out of the same farmland. Okay, and eventually it just suck all the nutrients dry out of it, unfortunately. Next thing, you got grazing range land with more livestock than the land can support. So basically now you're taking out all the plants that are holding that soil there and holding it sturdy, so it's easier to wash away and erode. Last one, is basically clearing forests on steep slopes with large clear cuts. And it's basically the same idea. It's basically deforestation on the mountainside. So you're taking out the things that are kind of like holding on to the soil. So if those things go, rain comes down, it's basically washing the soil away because there's nothing there to hold on to it. All right, page 223. Talk about desertification. So more than 10% of productivity is lost due to erosion all the time. And then villages are being buried due to human-caused desertification. And that's a bad thing. Like, take a glance at this picture. Literally, the desert is gaining ground toward the city because of what we're doing. We're basically degrading the soil so much. So it's basically creating dust bowls kind of everywhere. 224, like I just talked about, Dust Bowl is the biggest example of desertification hitting the U.S. And so, like you can see in this picture right here, just the amount of land that area, that the Dust Bowl took out. Okay, just absolutely wiped out just tons and tons and tons of farms and acreage and stuff like that. Now, the next thing we're going to talk about is the conservation methods. So we got to know these for examples on free response questions. So it's going to ask you things such as, like, what are some things you can do to basically increase or decrease soil erosion or increase conservation methods. So these are some really easy examples for us. Okay, first one, we've talked about this one already, is basically crop rotation. Okay, you move one crop here one year, and then you basically flip-flop them the next year, or move it to another section, and so on and so on. This contour farming, what that is, it basically makes it so basically on hillsides, there's less erosion. So basically the water can't just easily run down. You basically have kind of like little kind of stopping points or like little speed bumps per se. Okay, I'm going to move this sticky note so we can get down to the next one. Next one is called terracing, which is the same general idea as the contour farming, but now you're dealing with mountainsides. So now basically what they've done, they basically cut an edge and then they put a flat part. They cut an edge, then they put a flat part, and so on, so on, so on. It's the same general idea. Water can't just flow quickly down. It basically has to stop at certain spots to kind of slow itself down. Now this is called intercropping, which is kind of an interesting one. It's kind of like crop rotation, but more on like kind of like a lane by lane basis. You know, like so strawberries are right next to corn, which is right next to green beans, which is right next to, I don't know, spinach. Everything is kind of just intermixed with themselves. That's intercropping. Okay. Then you also have shelter belts. Excuse me. Shelter belts protect against wind eroding stuff. So basically, like you have the really low crop right there, but you have the taller trees, so if the wind comes in, it's not just going to blow everything away. Then I also talked about this one, what's called no-till farming. So basically, you don't, kind of rip up the soil every year. You basically just let kind of stuff grow through, is what's going on. Okay, and like I said, I'm going to move that back over there. Make sure to know what these are so you can use them as examples. Okay, the next page, 226, is I just simply wrote know these. All it is just kind of a more kind of a detailed version. Like you can see, it says contour farming right there. Right there, it says terracing. It's just kind of a bigger explanation than I got, or excuse me, than I gave. And honestly, I would do a quick read through so that way you understand it. Because I go quick. All right, next one. Let's talk about overgrazing. So this figure 9.22 will be asked about. Okay, and I'm going to drop down to that in a quick second. So ranchers overgraze, that BLM is Bureau of Land Management, which is basically public land. So the ranchers are overgrazing. They're basically just setting their cattle out there to go for it. Okay, this is a perfect example of tragedy of the commons. It's a common resource, so they're overusing it. Okay, this picture here is that figure 9.22. Okay, so you got overgrazing. Overgrazing does a couple things. It removes native grass, which exposes bare topsoil. Wind and water erosion happens. Decreases grass growth and survival, which goes back to removes native grass. Or it can go to invasive species. Or it can go to compact soil and damaged structure. Or the overgrazing just simply leads to that because they're walking around so much. That means the water can't get into it so much, decreases aeration. Aeration basically means that air needs to get into like the little cracks and crevices in the soil. Then invasive species can gain footholds. So basically, nothing good is coming out of overgrazing. But just be familiar with that because that question will be asked about. Or excuse me, be familiar with that figure because it'll be asked about. All right. This science behind the story is actually kind of interesting, talking about how ranchers and scientists working together. It's actually kind of cool because basically it's fun to kind of see and kind of refreshing to see the ranchers realizing that something needs to be done and being a participant in it. So it's kind of an interesting read that I like reading stuff like this. All right, last page. This is 230. So the government subsidies pay about 20% of a farmer's income. And the government is paying them to basically stop cultivating land that is prone to erosion. And cultivating land is basically like, kind of chewing it up so that way they can plant stuff on it. So they're paying them not to grow things to ensure that the land stays intact. Leave me some questions. Now we have stuff to talk about.